Okay, in this video we'll be looking at Tableau's area function and how you can use it to calculate the total surface area of any polygon in one of 4 units, so square meters, feet, miles or kilometers. This enables you to create charts from this new measure in the same way you can with any other measure in your data. I'll step through how to create this bar chart from a spatial file containing polygons of London districts, and how you can interact between the polygons and the bar charts. How you can also show the areas of polygons such as these London parks in other units such as acres and hectares by converting one of the 4 natively supported units using calculations. We'll also look at an example that highlights the importance of using accurate polygons when working with the area function. During this video I'll be connecting to a few different spatial files, and I'll add links in the description below where you can download these if you want to follow along. Okay, let's get started. Okay, in this first example, we're going to connect to a shapefile that has districts for all of the UK. So we'll just drop the file into Tableau, makes the connection. We'll go to the first sheet, and then I'm going to bring geometry into the view. Okay, and I'm going to break those up, all these polygons by the name. You can see we then have 363 marks in the view. Okay, next thing I want to do is just filter down to London only. So I'm going to drop this file name field onto the filters and just search for London. Okay, so we have all of the districts in London, and I want to show the area of each of these polygons. So there actually is an area field within this data set. So let's drop this into the view, and then what we can do is just select these polygons and just view the data. You can see that some of these are actually zeroed. So it's not so useful. So what I'm going to do is create our own area field using the area function in Tableau. This is a great use case to do this. So I'll take this old area field off. I'm going to create a new calculation. I'm going to call this new area. So you can see this function takes 2 arguments. We need to pass in a polygon and then the units that we want to calculate the area in. Okay, so I'm going to pass in the geometry that's in the view, which is the polygons for the districts. And I'm going to enter the code for miles for this function. So as I mentioned in the introduction, you can use 4 different units: miles, kilometers, meters or feet. And you can indicate these using shortened versions, MI, or you could type the word in full like so. Okay, so let's take this new area, drop it onto label, and you see that showing there now. I'm going to format the field to show 1 decimal place. Okay, then I'll just drop this field onto color as well. So I'm holding the control key and drag the field over to color. So just like any other numerical field in the dataset, we can use that calculated field for area to create another chart. So I'm going to create a bar chart using that same area. So I'll just add the names of the polygons in. And actually what I want to do is keep the same filter from the prior sheet. So I'll just go back, right click on here, go to apply this to all using this data source. You see we have an icon appear there. It just means it's going to be applied to any worksheet that uses the same data source. So now this is filtered down to just those London districts again. Okay, I'll take the new area, drop that on to columns to create this bar chart. I'm just going to sort that. And then we can just remove these headers. And then what I want to do is just shorten these names so they all have London Borough at the end. Okay, so to do that, I'll create another calculated field. I'll call this short name. So what this calculation is doing is calculating the length of this text that's at the end of each of these names, London Borough, and it's subtracting that from the full length of the name, and I'm taking the left number of characters that remains before London Borough, so Bromley, Hillingdon and Havering and so on. Let's click OK. So Bromley London Borough becomes Bromley, Croydon London Borough becomes Croydon, and so on. So there was one district that didn't have London Borough at the end, and that is the City of London, because it's not actually a borough of London, and that's a long story, but we'll just leave it there for now. So I'm just going to alias this to be City of London. Okay, so we can remove the original name from the view, and we just have the short names. Just going to sort this bar chart again. I'm going to bring this to color as well, and then just change that to use the same palette as we used in the prior chart. Okay, and then I just want to replace the name here with the short name as well, so as to be consistent. And I'll just edit the tooltip as well. Okay, pretty happy with that. So let's create a dashboard with these 2 views on now. Just going to remove the key for now. Okay, now because I have the same short name field on both of these, we can create an action between them. So it would be nice to have a highlight action so we can interact between these 2 views. To do that, I go up to dashboard, create action, create highlight action. I'm going to do this on select, and I want this just to run with the short name field. And I'm leaving both views selected so it works across the different views. Okay, so now I want to select the districts in the map. It's highlighting those in the bar chart. Likewise, I could select the top 5 and see where they are. See, these are the largest districts in London. That's just to add the area to the bar charts as well. We can just make those labels a bit smaller. Okay, I'm going to remove this header down here. And then we can just finish off by putting a title on the dashboard. And then I'll just hide the titles for the charts. Okay, so that's the first example of using the area function. Let's try another one now. We'll connect to a different data source. We'll look at some green spaces in London now. I'm going to create a new sheet and I'm going to connect to another file. Okay, so I'm going to drop this new spatial file into the view, and this contains parks and gardens across England. So I'll drop the geometry field into the view. You can see they're spread out all across England here. I'm just going to zoom into this area of London. And we'll just zoom in on these parks here. Okay, so as always, it's brought the geometry file in as one mark. You can see it on the lower left. So we want to bring in the name to split out the geometry. Okay, and I'll put actually the name onto label. So you can see Kensington Gardens, Hyde Park, and then I'll pick a few of these parks here as well. And we'll just keep only. So it applies a filter to that name. So now we just have these parks here in the view. So in this example, I'd like to show the area in acres, but acres is not natively supported by the function, so we need to calculate it from another unit. So to do that, we'll create another calculated field, and we'll call this area in acres. And then we start off with the area function as normal, passing the polygon and the unit. So I'm going to pass in miles. And then all I need to do to turn that into acres is just multiply it by 640. Okay, then we can add that calculation to the view. And then I'll just add acres after the number so it's clear. And let's colour these green, seeing as they're parks. So now we have acres on there. We could also add another custom unit on, which is hectares. Now we actually have hectares in the view, but I'll just show you how you can calculate that in case you need it. Okay, so to calculate hectares, you just calculate the original area in meters, and then you divide that by 10,000. Just format that as well. So that's how you can create custom areas using units which are not natively supported. So in this final example, I just want to demonstrate how important it is to have really accurate polygons when you're using the area function. So I'm going to connect to a spatial file that has polygons for the entire world. Okay, I'll bring geometry into the view again. And then I'm just going to filter to Monaco. Okay, and I'll just calculate the area in kilometers. So just the same way we've used the area function before. I'll drop that into the view. So you can see it's bringing back a result of almost 19 square kilometers. Now, in actual fact, Monaco is much more than that. It's just over 2 kilometers squared, according to Wikipedia. So you can see there's a big difference. And just to make that clear, I'll show Monaco in the background a bit more clearly by formatting the map. Okay, so you can see the outline of Monaco here. It comes around. It's a much smaller area than what we see here. So depending on the use case, if you're looking at all countries across the world, this rough outline for Monaco might be suitable. But in this particular use case where we're calculating an area, it's important that it's much more accurate. At the moment, this polygon is about 9 times the size of the actual area of Monaco. So the takeaway here really is the area function can only ever be as accurate as the polygons that you're using with it. So just to be aware of that. Okay, to finish up, here's a final example that I created for the 30-day map challenge a while ago. This is a really fun project that takes place once a year. I definitely recommend checking it out. I'll put a link in the description. The map actually focuses on population density in London. However, I also calculated the area of each London borough in the same way as we saw earlier in this video, and the value is shown in the tooltip. There's also interaction between the charts using a highlight action the same way that we saw earlier, and I'll put a link in the description where you can interact with and download this dashboard. Okay, I'll add some links on screen to some other videos that demonstrate some other spatial functionalities in Tableau. I hope that's been useful. Thanks for watching.